a lysimeter. And what they do is they just irrigate that crop, and they know and they're weighing this thing continuously. It's a continuous weighing scale underneath it, and so they're monitoring the weight. So they can water it up. Okay, they know when they get this big, huge tub, they're like 10 foot in diameter, and however deep you need to go to get the root depth you're after, 3, 4, 5 feet deep. Fill that soil profile to field capacity, and then let it sit that day and let the plants just grow, and over a 24-hour period you weigh it. And you know exactly how many pounds of water left that system over that 24-hour period of time, and you can calculate then how many total inches of water left that area over that 24-hour period of time. And then you can know that our consumptive use was 0.51 inches that day, or 0.32 inches that day, or whatever that depth calculated out at. We simply take the weight of the water, divide it by its specific weight, figure out the area, divide it into it, and you got yourself an answer, inches per day of actual use. Now, they've tested that with enough crops that they know what the different crops can do, and they have weather data matched up to that, and then they make this big mathematical model that says, well, we take into account the solar radiation, the wind speed, the temperature, the humidity, the big four, and figure out a way to evaluate this by a mathematical model. So we can take different weather conditions, we know it's going to have this effect on the consumptive use of this crop on a given day. And after you get enough data collected, you can make up a pretty good formula mathematically to tell you what's going to happen. And so now they put together these fancy methods that you read about in the text, and they talk about the Blaney-Criddle method in the textbook. It's a mathematical model for, they can do it monthly or seasonally consumptive use, and it's based off, it's for desert conditions. And so they base it off of air temperature and daylight hours. That's the two criteria they use. Air temperature and daylight hours. They say, the humidity stays pretty much the same. We're not going to get excited about that. In a true desert climate, that's pretty true. Humidity stays real low, doesn't have a huge effect. We're more concerned about cloudiness and about how hot it gets. And so they take temperature and daylight hours, and they make their model in an arid condition. And they know that this model works pretty good anywhere you go in the world. And so if you wanted to do a project in Pakistan, you could go into Pakistan and take weather records from an area for the last 10 or 20 years and model up pretty close what the consumptive use would be for any given crop that you wanted to grow there. And you'd be in the ballpark. You'd have a pretty good feel for how much water it's going to take to grow that crop. Now you can see the value of that, because then you could figure out, well, do I have enough water in the region to be able to actually irrigate enough viable acres to make this thing work? You know, how much can I really grow? How much can I gain in growth if I apply water? You know, and it gives you a model for being able to calculate that. So it's pretty valuable. Another one they list for humid climates, this guy named Thornthwaite came up with one. And again, you can read about it in the text. Just wanted to bring it up and point it out that it's there. And in humid climates, he said, hey, the critical things, again, are daylight hours, air temperature, and a heat index. And so they work off of a heat index that they've created. And then another area was a guy named Penman came up with one for arid climates and semi-arid climates, and he uses the 4 meteorological factors: wind speed, temperature, daylight hours, humidity. And there you're getting a much better model. You know, you're using all aspects to model with. And then they have, these have been what they call Modified. The modified Penman, or the modified Blaney-Criddle, or the modified Thornthwaite, they've changed the factors a little bit. They take the same concepts, but they've changed the multipliers a little bit for a given area so they can get it more accurate for a given area. And so if you wanted to do an evaluation of a little piece of ground here in Walla Walla County, they know that in this area the Blaney-Criddle method's a very accurate measurement of what happens. And they have a modified Blaney-Criddle method for the Pacific Northwest. You can just plug it right in and you can be very, very accurate on what your assumed use is going to be for a month or a season. It's hard to do it per day because days vary so much. But over a month you have a pretty good monthly average that's pretty standard, and so we can find monthly averages.